multiple inputs and giving one output. But here in demultiplexer, one input and that input is routed onto one of the output line. So there are multiple output lines. Okay. Multiplexer is called as many to one. And the demultiplexer is called as one to many. That is the difference between the multiplexer and demultiplexer. Now the select lines. Whatever the select lines are used into the multiplexer, the same formula is used into the demultiplexer. Now here, instead of considering the input lines to identify the number of select lines, here in a demultiplexer, the number of output lines are considered to give the identify the select lines. Now let's say 1:2 for multiplexer. Now in a multiplexer, we have seen the different types, that is 2:1, 4:1, 8:1, 16:1 and so on. Now in demultiplexer, we are going to see 1:4 or 1:8, 1:16, 1:2 and so on. Exactly opposite operation of multiplexer is going to be performed by the demultiplexer. Now let's start with the types of a multiplexer. Now the first type of a multiplexer, okay, before going to start the types of a multiplexer, just we'll see the functional block diagram of the demultiplexer. Now I'm going to draw the demultiplexer. Now this is, let's say, the demux. Now demux is a term which is used to represent the demultiplexer. The data input is taken. There is only one data input. This is a data input. Enable input is also required into the multiplexer. Similarly to the demultiplexer, this is 2:n demultiplexer. The data input is selected. Only one data input is selected and it is routed onto the n output lines. Now the outputs are like this. The output will be y0, y1, y2 up to the yn minus 2 raised to n minus 1. And the select lines are S0, S1 up to the Sn minus 1. S0, S1, S2 up to the Sn minus 1. These are the select lines. This is the block diagram of demultiplexer. Okay. Now the same circuit similarly to the multiplexer we can show. Let's say this is my demultiplexer block. Both the diagrams are same. You can draw the first diagram or the second diagram. Now it is up to you. This is the data input and the output lines. 0, 1, y raised to y, 2 raised to n minus 1. And the select lines are given like this. S0, S1 and Sn minus 1. These are the select lines. This is 1:2, 2 raised to n Tmux. Both the circuits are same. You can use the first circuit or you can use the second circuit to represent the demux. As I told, in a demultiplexer, there is only one data input and the data input is routed onto one of the output line. Now, based on to the output line, the number of select lines need to be identified. If I am saying that there are 2 raised to n output lines, then n is the select lines. 2 raised to n output lines, then n are nothing but the select lines. Okay. Now if I am saying that I have a 1:4 demux, then 4 are the output lines. Now when 4 output lines are there, then 2 raised to n is equal to 4. So n is equal to 2. Now the select lines will be 2 and data input will be the 1. Now data input we are going to represent with the term D. Output we are going to represent with the term Y, and select lines we are going to represent with the term S. Okay. Now let's start with the 1:4 demultiplexer. Now when the 1:4 demultiplexer we are going to represent, let's say this is my 1:4 demultiplexer. I'm going to give one data input. This is the data input D0 or a D in I can represent, and the output lines are 4, 1:4. So this will be my Y0, Y1, Y2 and Y3. Y is nothing but the output. These are the outputs. And the select lines, there will be two select lines. So the select lines now I am going to represent here S0 and S1. Along with this, compulsory I have to give the enable input. Unless and until we are not giving the enable input, the circuit will not get enabled. So for the active low or active high based on to the IC, the enable signal will be having the 0 for active low signal and 1 for the active high signal. Once the enable signal is activated, based on to the select lines, the demultiplexer will route the data input DN either onto Y0, Y1, Y2 or a Y3. Okay. Now let's see the functional truth table of the 1:4 multiplexer. Now in the 1:4 multiplexer, the first input we are giving to the demultiplexer is the enable. Now here from the block diagram of the 1:4 demux you can see the inputs we have given to 1:4 demultiplexer are, the first one is a enable, then second input is the select lines. First is enable input, second input is select lines. Now select lines I am using in the sequence S0 and S1, and third input is the data input. These are the inputs. Okay, and output is generating as Y0, Y1, Y2 and Y3. These are the four outputs which are generating by the 1:4 demultiplexer. Now we'll see the truth table. We'll identify the truth table. For the active high enable input, the enable value should be 1. For active low enable input, the enable value should be 0. Now let's say my enable input is active high to enable the 1:4 multiplexer. So for the value 1, enable signal is getting activated. The data input will be either 0 or either 1, as there is only one input we are giving to the demultiplexer. Now when the input is a 0 or a 1, based on to the select lines, the input is going to be routed onto the Y0, Y1, Y2 and Y3. Now when my select lines are 0, 0, when the select lines are 0, 0, then data input, whatever available onto the DN line, these are displayed onto the Y0 output line. When the select lines are 0, 1, when the select lines are 0, 1, at that time the data input will be either 0 or either 1, whatever it will be. Then at that time the output is displayed onto the D in input is displayed onto the output line Y1, that is a 0, 1. Similarly, when the select line inputs are 1, 0, then at that time the data input whatever available is displayed onto the Y2 output lines. Y2. Similarly, when the select lines are 1, 1 and the data input will be either 0 or 1, the output is displayed onto the Y3 output lines. Now at that time when the particular output line is selected, at that time the data inputs are going to be displayed onto the output line. and at the time the remaining output lines are displaying the output as a 0 0. Now here I am going to show the output lines now as a 0 0 0 0 0 0. Similarly here when the select lines are 0 1, the D in is displayed onto the Y1 and the remaining output lines are displaying the output as a 0 0. When select lines are 1 0, then the input is routed onto the Y2 lines and the remaining output lines are displaying the output as a 0 0. Similarly, when the select lines are 1 1, the data input is routed onto the Y3 and the remaining output lines are displaying the output as a 0 0. Clear? And when the output is going to be routed onto the output lines, the enable signal is a active high. Now it is possible that the enable signal is active low. Now based on to the question whether it is active low or whether it is active high enable input, you have to write the enable input value either as a 1 or either as a 0. Now here as I am saying that the enable input is active high, that's why I am giving here the enable input as a 1 1. When the enable input is a 0, then whatever the input is available onto the select lines or the output lines, it is not going to be affect onto the output. The output lines are going to be displayed simply the output as a 0 0 0. Select lines and data lines are not going to be considered. This is the functional truth table of 1:4 demultiplexer. Now once we'll identify the truth table, now we have to identify the Boolean expressions and we have to design that by using the logic circuit. Now for this one, when the select lines are for y0, the select lines are 0 0. So I am going to write the expression for y0. Y0 is equal to S1 0 S0 bar enable and data input. Whatever the data input is having 0 or 1, it is going to be displayed. That's why I am going to write here the DN. Similarly, the expression for Y1 is equal to S1 bar, then S0, then enable the data input. The expression for Y2 is nothing but the S1 S0 bar enable input data in, and Y3 is equal to S1 S0 enable and data input. Now once we'll identify the Boolean expressions, now we can design the logic circuit easily by using the different logic gates. Now we'll try to implement the Boolean expression by using the logic circuits. Now the common inputs I am going to use as S0, S1 and the enable input. Now this is the S0, S1, enable and the data input. Now S0 and S1 I have to use into the inversion form also. So I am going to use a NOT gate here, which is giving me the S0 bar and S1 and the enable input. Now we'll implement the Y0 first. Now for a Y0, the data inputs are, now I am going to use the AND gate. The inputs to the first AND gate to give the output as a Y0, these are S1 bar, S0 bar. The enable input and the data input. It is giving me the Y0. Now the next is Y1. For a Y1, I have to give the input as S1 bar, S0, enable input and the data input. Similarly for a Y2, we have to give the input as S1 and S0 bar. This is a S1 and this is a S0 bar. Enable input and the data input. And for Y3, I have to give the S1, S0. S1, S0, enable input and the data input. This is the logic diagram for 1:4 demultiplexer. This is the block diagram of 1:8 demultiplexer. There is one data input, one enable input and the select lines. Now when I'm saying that there are 8 output lines. So 2 raised to n is equal to 8. So n is equal to 3. So the select lines will be 3. Now the select lines I'm going to write S0, S1 and S2. S0, S1 and S2. Select lines, and outputs will be Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Now based on to the select lines, 1 has to 8 demultiplexer selects one of the output line to route the data input as a output. Now let's see the function table of the 1 has to 8 demultiplexer. Now the data inputs taken are enable input, then the select lines and the DIN, that is a data input. Now the data input may be either 0 or either 1. So directly we'll consider the data line. Now the select lines are S0, S1 and S2, and outputs are Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7.
Ma'am, where is the input column?
Now the data input will be either 0 or 1. Now here, if you will observe into 1 has to 4 demultiplexer, whatever the data input D in, that is 0 or 1, is going to be displayed onto the output line as it is. Now here, instead of writing the D in 0 and 1, now I am going to write here the directly data in. Okay, for both the cases, the data input will be the D in. That's why I am going to write the directly value. Okay.
Yes, ma'am.
If you write only the function table will be growing. It is increasing the rows and columns. Okay. Instead of that, directly I am going to write the variable name data input. Okay. Now, if I am saying that the enable input, let's say for a active high data enable signal. Now remember here, based on to the enable signal is activating the chip either for active high signal or active low signal. Based on to that, you have to write the enable signal value either 1 or 0. Now I am saying that it is activating on the active high signal. So the enable signal will be 111 for all the cases. Now 3 select lines. So possible input combinations are 3, 2 raised to 3, that is a 8. So 0, 0, 0 to 8. Now for these possible input combinations, the outputs. Now when S0, S1 and S2 is equal to 0, 0, 0, whatever the data input is available is going to be displayed onto the Y0 output line. When S0, S1 and S2, these are 0, 0, 1, then the data is going to be displayed onto the Y1 output line. Where for a 0, 1, 0, the data input is going to be displayed onto the Y2 output line. For a 0, 1, 1, it is going to be displayed onto the Y3. Then for 1, 0, 0, it is going to be displayed onto the Y4. Then Y5. Then Y6. And then Y7. 1, 2, 3, 4, 5, 6, 7, 8. And for the remaining times, the output is going to be displayed as a 0, 0, 0. Now you can show here the truth table like this also. And so on. For the remaining time, you simply write down here the outputs 0, 0, 0 on all the output lines. And so on. Clear? Now once you'll identify the functional truth table. Now if the enable signal is a 0, whatever the select lines will be there, the output is going to be displayed as 0, 0, 0 and so on. Got it? Now this is a function table of 1:8 demultiplexer. Now based on to the function table, now we can identify the expressions for y0, y1, y2, y3 up to the y7. Now y0, now let's try to identify the expressions. Y0 expression will be S0 bar, S1 bar and S2 bar, and the enable and the data input. Enable and data input, these are common in all expressions. Y1, S2 bar, S1 bar and S0. Y1, S2 bar, S1 and S0 bar. Y3, Y2, S2 bar, S1 and S0. Y3 is equal to S2, S1 bar, S0 bar. Y4, Y5 and Y6. 2, 3, 4, 5, 6. Or you want to implement 1:8 demultiplexer using 1:4 demultiplexer, then what you will do? You will use two 1:4 demultiplexers and you can implement and design the 1:8 demultiplexer. Now how to design 1:8 demux using 1:4 demux, that we'll see here, which is nothing but expanding the demultiplexers or using demultiplexers into the cascading modes. Now I have to use two 1:4 demultiplexers. The first one is 1:4 and second one is a 1:4 demultiplexers. The first data input is given to the multiplexers, data in. Common input we can give to the second multiplexer, that is nothing but the data input to the demux. The enable input need to be given to the first and second multiplexer and the select lines. Now 1:4 demultiplexer is having two select lines, but 1:8 demultiplexer needs the three select lines. So the common select lines S0, S1 of the first demultiplexer and second demultiplexer we can connect together by giving the common inputs. Okay, and the enable input now we can give as a third select line of the second and the first demultiplexer. Now we are giving here the input. This is the enable input and the input given as the third select line. Now let's say these are the select lines. These are the select lines. This is the data input. and these are the outputs. Now outputs you have to show. It is 1:8 demultiplexer. So one data input is given, 3 select line inputs have given, and the 8 data inputs now you have to show. This is Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. This is the cascading, or you can say that the expansion of demultiplexer. Similarly, now when the enable input is given, the third select line input, when the enable input is given, when E is equal to 0, then at that time the first demultiplexer will be get activated. When E following function using demultiplexer. Now when the question is given like this, we have to implement a particular function by using the demultiplexer. And let's say the function is given like this. Let's say f of ABC is equal to summation of m, suppose 2, 3, 5 and 7. Now the Boolean function with the 3 variables A, B, C, which are acting as the select lines into the demultiplexer, and the mean terms have a given 2, 3, 5 and 7. Now we want to implement this function by using the demultiplexer. Now we know that 3 variables A, B, C means there are 3 select lines available into the given Boolean function, and these select lines are routing the output onto the output lines 2, 3, 5, 7, which are represented here as a min term. Now to implement the function by using demultiplexer, what we have to do? We have to select the min terms from the function and we have to OR together to give the particular output. Now let's say I have a demultiplexer. Now my first task is identify what type of a demultiplexer is required to implement a particular Boolean function. Now based on to the number of min terms, now we can identify the Boolean, we can identify the type of demultiplexer. Now the maximum number of the min term is a 7, means there are possible 8 outputs will be there into the demultiplexer. So I can use 1:8 demultiplexer. 1, 2, 3, 4, 5, 6, 7 and 8. These are the output lines. Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Now the input, data input, you have to give to the multiplexer as a value 1. The data input is given as a value 1. Remember, the enable input is also given to the demultiplexer. Now, if the question is saying that for the active low signal, the demultiplexer is selecting the particular output, then implement by using a Boolean function. Then at that time, based on to the active high or a low, you have to give the enable input either 0 or either 1 based on to the question. The select lines, 3 select lines are given, that is a ABC, which are connected to the S0, S1 and S2 to the select lines. And the outputs, now the terms 2, 3, 5 and 7, these are giving the outputs to the given Boolean function. So the pin number 2, then the pin number 3, then 5 and the 7. Now these are all together to give the output. And this is nothing but our final F of A, B, C. This is the implementation. The data input is given. Enable input is also given. No need to show here enable input. If you want to show, it's fine. If you don't want to show, again it will be fine. And the select lines A, B and C as it is given in the truth table ABC variables, we have to write here ABC. S0, S1 and S2, and the outputs will be 1, 2, 3, 4, 5, 6, 7 and 8. Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Okay. Now to implement the Y, the outputs given are 0, 1. Now the 0, 1, 2, 3 and 3. These are all together. Okay. To give the output Y. And for Y1, the outputs are 0, 1, 2, 3. 2, 3, then 4, 5, 6 and 6. These are all together to give the Y1. Okay. This is the 6,